Now we get into buffers. So here's the first problem. What is the pH of a solution that is 0.405 molar HCOOH, which is formic acid, and 0.326 molar of the conjugate base of the formic acid? Okay, and then the Ka is given to us 1.8 times 10 to the negative 4. Okay, so I'm going to do this problem in two different ways. Okay, because the buffer equation, the Henderson-Hasselbalch equation, is pH is equal to pKa plus log of base over acid. Okay, and remember this is all of the log of base divided by acid, not just log of base. Okay, so that is our Henderson-Hasselbalch equation. But where is that equation actually coming from? That equation is actually coming from H3O plus concentration is equal to Ka, and you can see the resemblance in the equation, times, but in this case the acid is on the top and base is at the bottom, is the denominator. So that's the only difference between them, and by the time you rearrange and do the log of this, it's slightly rearranged. So I'm going to go ahead and do both of these for you, and you will see they're both the same. Okay, and you can do it either way that you want to. So the hydronium ion concentration here is what we are calculating for, because that's what's going to give us the pH. And so Ka is equal to 1.8 times 10 to the negative 4. Our acid concentration is 0.405, and our base concentration is 0.326 molar. And so once you calculate all of this, it's going to be 2.24 times 10 to the negative 4, and that's the hydronium ion. So then take the negative log of 2.24 times 10 to the negative 4, and you get the pH of 3.65. Okay, so this is one way of doing it. In order to do it by the Henderson-Hasselbalch equation, you can calculate the pH directly, but then first you need the pKa. pKa is the negative log of 1.8 times 10 to the negative 4, and then plus log of base over acid. Okay, so now everything is reversed, so which means base is 0.326, and then your acid is 0.405 molar, not that zero. Okay, so those are your concentrations. Okay, and so then once you do the calculation for all of this, this will be 3.74. that is what the pKa is, and then plus you will take the log of, and once you do the calculation of 0.326 divided by 0.405, you should get 805. So find the log of this, and it should be a negative number, and so then your pH is 3.65. so you end up getting the same numbers. It's just a matter of which way you prefer. If you don't want to use the Henderson-Hasselbalch, you can use this. It's absolutely fine. I will give you both on the test, so you can decide whichever one you want to use. Okay, I have no preference whatsoever. So here's the next question then. How many grams of ammonium sulfate must be dissolved in 0.100 liters of 0.35 molar ammonia to make a buffer of a pH 10.05? And then the Kb is given to us. Okay, and so again, for us, we will need our equation, which is H3O plus is equal to Ka times, again, acid over base concentration. So what do we need over here? Ammonia is given to us. Okay, so if ammonia is given to us, we have the base given to us, so we need to calculate the acid. That's what we need. And then of course we need to calculate Ka, because we're given Kb. So let's go ahead and start working on those things. And the pH is also given to us. We need to find the negative log of that. Okay, and so, or anti-log of that. So let's find the Ka first. So Ka is equal to 1 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5. And so that is 5.6 times 10 to the negative 10. That is our Ka. And anti-log of 10.05 is equal to 8.91 times 10 to the negative 11. Okay, so those are what we need in order to get started with this problem, and then we shall calculate the acid concentration that we need. So H3O plus, which is 8.91 times 10 to the negative 11 is equal to Ka, which is 5.6 times 10 to the negative 10 times the acid, and acid is what we're looking for, and the base concentration is given to us, which is 0.350 molar. Okay, that's the base concentration. So after doing the whole calculation, your acid calculation should be 5.6 times 10 to the negative 2 molar. Okay, but this is the concentration of the solution. What you need is how many grams. Okay, that's what the question is asking for. So which means we need to convert the moles into then grams. But then we know that we are only making 0.1 liter, not 1 liter, and this is molarity is moles over 1 liter. Okay, so we need to work on that stuff also. So here is our setup then to find out the grams of ammonium sulfate. This is going to be equal to, and we start with what we know, which is 5.6 times 10 to the negative 2, and I'm going to go ahead and write my units out. Okay, moles over liters. And how many liters do we have? We have 0.100 liter, and now I'm going to go ahead and convert my moles, and so this is ammonium sulfate. Okay, remember ammonium sulfate is NH4 2SO4. So in 1 mole of NH4 2SO4, I have 2 moles of ammonium ion, and I'm sorry, over here it should be, this is ammonium ions, because that's what the molarity is for. It is for ammonium ions and not for ammonium sulfate. Okay, so every 1 mole of ammonium sulfate has 2 moles of ammonium ion. So we need to make sure we divide this concentration by 2, and then you find the moles of ammonium sulfate. So that is 132 grams over 1 mole of ammonium sulfate, and this is equal to then 0.37 grams. So which means you need to dissolve 0.37 grams of ammonium sulfate in 0.1 liter of a solution of 0.35 molar ammonia, and that will give us a buffer of pH 10.5. So again, the mole ratio here was an important thing because you had 2 moles of ammonia in 1 mole of ammonium sulfate. If we were dealing with ammonium chloride, then you would not have to work with the mole ratio, because in 1 mole of ammonium chloride you have only 1 mole of ammonium ions. Okay, but here because we had 2, we had to work with that mole ratio. Okay.